Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at the quadratic formula. Now let's say we wanted to solve this equation here, a quadratic trinomial. So we would need to find two numbers that multiply to -2 and add to give +2. So you probably think there are no such numbers. It turns out they are, it's just the numbers are really complicated. So it turns out the two numbers that multiply to -2 and add to 2 are 1 plus √3 and 1 minus √3. So this number here is about 2.73, blah, blah, blah. This is minus 0.73. There is no way you'd be able to come up with, on the top of your head, these two numbers. So if I went to solve this equation, it'd just be the negative. It'd be -1 plus √3 would be one solution, -1 minus √3 would be the other solution. We need a way to come up with solutions like this without using factorization, because factorization won't always work. So we're going to use a method that doesn't involve factorization at all. It is a formula. So before we go through the quadratic formula, I want to go through what's called the discriminant. So the discriminant of any quadratic equation is very useful. We calculate it first before using the quadratic formula. The reason is the discriminant tells us how many solutions there will be. If the discriminant's greater than 0, there are two solutions. If the discriminant equals 0, there's one solution. And if the discriminant's less than 0, there are no solutions. So the discriminant of any quadratic is equal to b squared minus 4ac. So what is a, b, and c? They're the coefficients in the equation. So for this equation up here, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So a in this case is 1. X squared and 1x squared are the same. So if there's no number written in front of x squared, then a is 1. B, the coefficient of x, the number in front of x is 2. And c, the constant term is -2. So let's calculate the discriminant for this equation here. So the discriminant would be b squared minus 4 times a times c. So if you put this on your calculator, you actually get 12. So the discriminant is 12. It's greater than 0, so there are two solutions. And we already knew that there were two solutions. But when we're using the quadratic formula, we calculate this discriminant first. We can actually use it in the quadratic formula now. So what actually is this quadratic formula? So this is the quadratic formula. You use it when you're solving equations of the form ax squared plus bx plus c equals 0. One side has to be equal to 0. Then we can use a formula, just plug in a few numbers, it'll tell us what x is. So the quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac over 2a. I know it looks really complicated. So first, what is a, b, and c? Remember, a is the coefficient of x squared, b the coefficient of x, and c the constant term, just like on the previous slide. So notice that this here is the discriminant that I talked about on the previous slide. So that's one reason we calculate the discriminant first. It's part of the quadratic formula anyway. So this quadratic formula potentially has two solutions. Minus b plus the square root of the discriminant over 2a, and minus b minus the square root of the discriminant over 2a. So let's go back to our equation from the previous slide. So we had x squared plus 2x minus 2 equals 0. So we figured out a was 1, coefficient of x squared is 1, coefficient of x is 2, constant term is -2. We also calculated that the discriminant was equal to 12. So rather than trying to factorize this, we can just put these numbers into this equation here. The solution is x equals minus b plus or minus the square root of b squared over 2 times a. So there are two solutions here. -2 plus the square root of 12 over 2. And the other one is -2 minus the square root of 12 over 2. So if you put these in your calculator, this one here gives you about 0.73, and this one gives you about minus 2.73. And these are the same answers we got on the previous slide. This just makes things a lot easier. All right, let's try another example now. So let's have a look at this equation here. 2x squared plus 8x plus 11 equals 0. So if we wanted to solve this, we wouldn't be able to factorize it. You can't actually factorize this. So let's try using the quadratic formula. So first step, calculate the discriminant b squared minus 4ac. So here, b is 8, a is 2, c is 11. So the discriminant is b squared minus 4 times a times c. Now, if you put that in your calculator, you get minus 24. As I said on the previous slide, if the discriminant is less than 0, there are actually no solutions. So that's another reason why calculating the discriminant to begin with is a good idea, because there's no point me trying to use this formula when there are no solutions. I don't need to go any further with this question. There are no solutions. I can't use the formula, so I'm done. Let's look at another example. So let's have a go at this question here. We've got a quadratic trinomial, but the number in front of x squared is not 1, and there is no common factor between the three terms. So what that means is we would not be able to factorize using the methods that we know. So lucky we have the quadratic formula. We can solve this without factorizing. So here, a, the number in front of x squared is 4, b, the number in front of x is minus 20, and c is 25. We first calculate the discriminant. So it's b squared, whenever you're substituting a negative, put in brackets, b squared minus 4 times a times c. So if we put this on a calculator, we actually get 0. The discriminant of this is 0. It will only have one solution. So now, because we know it does have a solution, let's use the quadratic formula. So we have x equals minus b, so minus 20, so plus 20, minus b plus or minus the square root of the discriminant, which we calculated was 0, over 2 times a. So the solutions here are 20 plus 0 over 8, which is 20 over 8, or 20 minus 0 over 8. But 20 minus 0 over 8 is the same thing, 20 over 8. And you can also write that as 5 over 2. There is only one solution here. X is 2.5. All right, now we're going to look at something slightly harder. We're going to use the discriminant to calculate one of the coefficients. So in this question, we have the quadratic equation x squared minus 8x plus k equals 0. We don't know what k is. We're going to figure out what k is if this equation has one solution and if it has no solution. So whether it has one or no solutions is totally determined by the discriminant. So the discriminant of this equation, so a is equal to 1, the number in front of x squared, b is the number in front of x minus 8, and c is like k. So the discriminant is b squared, so we're putting it in brackets because we're substituting a negative, b squared minus 4 times a times c. So if there is only one solution, this discriminant will equal 0. So the discriminant is 64 minus 4k, and that equals 0 if there's only one solution. So if 64 minus 4k equals 0, you know how to solve this. We're just going to subtract 64 from both sides and divide each side by negative 4. K equals 16. If you have x squared minus 8x plus 16 equals 0, that has only one solution. The only solution to that is x equals 4. So what about if it had no solutions? Well, that would mean here that 64 minus 4k is less than 0. So rather than going through these processes, we know it'll have to do something with 16. 64 minus 4k will be negative, less than 0, if k is greater than 16. So if you have something like x squared minus 8x plus 17, k is 17, for example, if you have x squared minus 8x plus 17 equals 0, there would be no solution. Any value higher than 16, there'd be no solution. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.